Hello, everyone. I am Fatma Samir, and this is my colleague Yahya. We are technical learning designers at Sana Academy, which serves as the educational arm of Sana Tech, the parent company of Fab Egypt.
Okay, hello everybody. I am Yahya, and we are happy to be here to share our journey of empowering educators' experience. At Sana Academy, we provide a human-centered, tech-enabled learning. Over the years, we nurtured a network of 2,800 alumni.
In Egypt, traditional education faces major challenges. We see it every day, a lack of resources, undertrained teachers, and passive learning style that prioritize passing exams over building real-world skills. At Sana Academy, we are shifting from the focus of knowing to doing. That's why we created Nortec, a 3-year project supported by Drosos Foundation and designed, implemented by Sana Academy to revolutionize STEAM education in both Cairo and Aswan. We are tackling the challenge through 5 initiatives. The first initiatives, we are establishing innovation hubs in both Cairo and Aswan to provide physical infrastructure to solve the resources gap. And here come our core of the program. We are empowering the heart of the classroom, the teachers, through our EduMakers diploma. While our EduMakers Fellowship puts stipends and hardware directly into the hand of educators to apply their knowledge into the classroom, we replace rote memorization with hands-on invention by introducing 1,500 students to digital fabrication via STEAM clubs. We are also launching an Arabic maker education platform that enables teachers to document and share their lesson planning with community of teachers and makers, ensuring the learning is continuous journey of discovery in our native language. You can think of Nurtec as the body and EduMakers diploma as the heart. It's an 11-week intensive program. The program consists mainly of 2 parts or 2 phases. Each phase concludes with a capstone project. So in phase 1, we cover the foundations, where we integrate maker pedagogy and physical computing. By the end of this phase, every teacher designs their first classroom experience using the 5 E's instructional model. And in the second phase, we move to innovation and fabrication, where teachers design, we teacher learn design thinking and use Tinkercad, 3D printing, laser cutting to create fully functional smart project prototype.
Okay, to validate this educational structure, we conducted a 5-week pilot program in summer 2025, focused on phase 1. We needed to ensure that this integration between technology and pedagogy would work across diverse Egyptian educators before scaling up to the full diploma. Our pilot included 6 educators representing math, science, art, and ICT backgrounds who taught elementary and middle school, including junior and senior level. Through the pilot journey, we focused on the maker mindset to understand the needs of their student, in addition to learning how to build smart project using Arduino and block-based programming. We assess their growth in active and maker pedagogies. We use maker journals and portfolios, focusing on the learning process rather than just the final product. We capture how educators develop over time through creating lesson plans that utilize physical computing to facilitate the learning of educational concepts in different subjects. And this brings us to some concrete outcome, like our first lesson, how to calculate area for lower grades in elementary school. A math teacher who designed a lesson using cardboard and basic electronics. Students don't just calculate area on paper, they build an interactive project using electronics component like ultrasonic module, LCD screen, and set of buttons that are controlled by Arduino board, proving that abstract concept can become meaningful student-centered experience.
Our second outcome is a science lesson that explains how temperature affects particle motion concepts for middle school students. Our teacher created a device that uses a DHT11 sensor to visualize molecules vibrations as the heat increases using servo motors. This project successfully bridged the gap between an invisible microscopic concept and a real-world sensing experience. And now we want to share some critical insights regarding our pilot phase. So we encountered significant resistance to change, particularly from those who have spent many years with traditional old school frameworks. We realized that their resistance isn't a barrier, but a specific need, actually. We dealt with this resistance through empathy, both in our sessions and in how we developed our curriculum after the pilot. This approach allowed us to refine our modules to better support educators as they transition away from decades of direct instruction to guided discovery. The second insight, we noticed a struggle in implementing inquiry-based learning in lesson planning using the 5Es instructional model. We approached this challenge through extra practice sessions for 5Es planning. And moving forward, we are planning to provide prepared lesson plans in different subjects as examples to be inspired.
Okay, one of our favorite success stories is a math teacher. She works in a community school supporting students who have dropped out of the formal system. She had no experience with electronics and didn't written a single line of code before. But what she achieved during the program amazed us. She not only completed the diploma, but also joined the fellowship, bringing her student into the lab, building and create incredible projects. Today, she is proud and she is an active member of our maker community. So, what's next? Our mission now is to turn these individual success stories into a national-wide standard. In June 2026, we will launch our next major phase, reaching 120 educators from Cairo to Aswan. One of our primary challenges is the highly complex paperwork and administrative hurdles we face when working with the schools. This bureaucratic friction is a real-world bottleneck, but often threatens to stop the momentum of our diploma ends. The momentum, sorry, of our educators after the diploma ends. This is exactly why we focus so heavily on the fellowship. We plan to initiate a collaboration with the Ministry of Education here in Egypt or school leadership boards, which empowers educators by removing these administrative challenges. Behind the scene, there is a massive amount of work, dozens of detailed insights that can be discussed to speak about this experience. So if you have any questions, our door is widely open. For the few minutes we have till the end of this breakout session or later via our email. Thank you. Okay, we can check for.
So does anyone have any questions for our speakers? Well, I have one. Maybe I missed this, but do you work with any particular age group or like elementary students in high school or?
No, we are targeting teachers from both elementary, middle school, or high school. But actually, in this pilot, in the pilot of phase 1, we were targeting elementary and middle school teachers.
Okay, Ebenezer has a question. Go ahead.
Yeah, my question is to the presenters. What are the resources or the material that you use in your design for these projects and for the classes? The sources of the materials, the kind of nature of the materials you use for the design, and if possible, the kind of the teacher, is it a trigger only mathematics or science aspect, or those teaching art subject, can they still apply the method in their teaching? Thank you.
Okay,
Thank
you
you.
meant like instructional design methods?
Yeah, what I ask is the design methods, this your curriculum and the model, your prototyping that you use in the classes. So I mean, what are the materials, or is it just ordinary theoretical curriculum? Or is there a kind of any material you use for, as you just said about maybe the teaching of square or teaching of this? Is it, do you use cardboard sheet, or do you use a plastic waste, or do you use, these are just materials you use as the instructional material you use for the classes? Is what I want to know before you talk about if it's only directed to towards sciences only or mathematics, or is it any educator, whether it's teaching literature or teaching art, can apply the same method. Sorry.
Yeah, okay. For pedagogical instructional methods, we use the 5 E's instructional model, which target of 5 phases. Um, uh, and for physical computing, they were using M-block for coding. They using cardboard to build a prototype, actually.
Maybe I can give him some uh, sort of what practices we used in Sana Academy. We have our team is very experienced in designing learning experience across multiple programs. We have programs like Maker Diploma, Girls Make, and many other educational programs. We mastered kind of instructional methodologies in teaching electronics and design, and this helped us a lot in designing this experience for educators. There is no solid reference for this material. It's all designed and developed by Sana Academy team. Yeah. I think we have some questions in the chat.
Yeah.
Yusuf is asking, is this experience transferable to college experience? I think so, but it will have a set of challenges. This learning experience, I think it's can be modular and be plug and play with different setup. Uh, but as the college experience may have, I don't know, technical depth, different technical depth rather than the school subjects. This can have some challenges, but it's transferable with some concerns, I mean. I hope I answered your question. Uh, okay, Lamia is asking, how would you ensure the commitment of the teachers for the duration of the program? So Fatma, if you can go for it.
Okay, we are considering this thing in the interview phase when we were interviewing with teachers. We are guarantee that we asking them if you had joined any program for like training for teachers before, how many hours did you commit, so we can uh, know their commitment from the prior experience, actually.
And I put the next question was, could you contact mail in the chat? So I did that so you don't have to.
Yeah.
Thanks a lot. Okay. I think I can stop share.
Any other questions for our speakers? Or is presenting, is it like the middle of the night there right now?
No, not the middle of the night. It's 10 p.m. here in Egypt, so not too late.
So Isra raised a hand. Go ahead.
So if you can share experience from the teachers who implemented the methods with their children in schools. So how they felt the difference between the original way of teaching and implementing the new teaching methods they learned from the program.
Okay, actually, I can come back to the the case we mentioned in the presentation. Learning in Egyptian classes is still very traditional, one-way direction from instructor from the teacher to the student. Focus on passing exam rather than just learning new things. For example, the area calculation lesson or the calculation of the area, this lesson is introduced for young kids in primary schools. And we have this teacher who made a whole project. The project students build a cardboard model with built-in ultrasonic sensor and LCD, all programmed with Arduino and micro and M-block to program the Arduino. And the student know what is the parameters of measuring the distance rather than just memorizing functions or applying direct instructions. So this transfer was notable as one examples of our programs. And she's the same instructor who proceeded with the fellowship, by the way.
I have a question.
Yes, please go ahead.
Yeah.
You've mentioned on a couple of occasions using both M-Block and Arduino. I know that in the documentation for M-Block, and this may be a little too technical, not that I don't think you'll have an answer, I just don't know that it's as interesting to everyone else here. But have you had much success with getting the M-Block software to interface with other Arduino products and vice versa?
I can get the point. I am the one who was delivering the physical computing module, and connection between M-Block and Arduino sometimes have some challenges. But after a couple of projects, we developed like debugging list or checklist. If this happened, then try this. If the connection broke at this point, then do that. I don't know if this is the point you are asking for.
Yes.
Yes, Mblock is not the smoothest software to integrate with Arduino, and it has
That
some
is
set
what
of
I know.
challenges. Yes, I know that. But building many projects and troubleshooting time after another. And guys, we love reflection. We in the Sana Academy team, we stop every 5 minutes and stop, reflect on that, document it, write it down somewhere. And with each problem, each troubleshooting case, we kind of document it. And after a while, we have set of use cases or checkboxes or troubleshooting guide. This was provided to the educators or the students in this program or other program. I think also we have another program we use MBlock with Arduino. And this was like solid knowledge. Now we can overcome most of challenges.